Okay, so let's see what we can do here now. So the next thing we need to do is now split this into a bunch of limits. All right, so we're going to have the following. The limit as delta x approaches 0 of g of x. The limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x minus the limit as delta x approaches 0 of f of x times the limit as delta x approaches 0 of g of x plus delta x minus g of x all over delta x. And then, notice that this is a fraction multiplying all this, so we'll go back to a complex fraction. This is all going to be divided by the limit as delta x approaches 0 of g of x times g of x plus delta x. Alright, so now that we have this, hopefully some good things start happening here. So let's see, as we evaluate the limit as delta x approaches 0 of g of x, that's just g of x. Okay, this limit here, this is a definition of the derivative of f of x. So that means this is f prime of x. Then we have a minus. The derivative as delta x approaches 0 of f of x is just f of x. Okay, this here, the limit as delta x approaches 0 of g of x plus delta x minus g of x over delta x, that's the definition of the derivative of g of x. Okay, and then this is all going to be over g of x. So as we substitute in delta x for this, we get g of x and g of x. This x plus 0 is just x. Alright, so there is our quotient rule. So the quotient rule says if y equals f of x over g of x, then derivative is going to be g of x, f prime of x, minus f of x, g prime of x, all over g of x squared. Okay, so this one is a little bit more involved than the product rule. So there's definitely ways where we have to try to remember what the quotient rule is. And so there are two ways that I have seen. And the first way is the way I use. And so it's the derivative of a quotient equals. And so when we have a quotient, we have a top and a bottom. So instead of saying numerator denominator, we actually have a top and a bottom. And so what we do is we say, okay, it's the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. That's what this says. Top times, the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Okay. And then the other way I've seen over time that has been used is this kind of phrasing, and the way we say it would be low d high minus high d low all over the square of what's below. And so this makes sense. You have the low, which is the bottom, d high, so this means taking the derivative of the top, minus high, d low means the derivative of the bottom all over the square of the bottom. So somehow you have to remember this quotient rule because, of course, you don't have formulas or anything. But one of these two is usually the students kind of figure out one they like and then they use that one. The other thing I want to emphasize is that when you use the quotient rule, order does matter. Okay, and this is kind of key because in the product rule, because of the commutative property, the product rule is actually fairly forgiving. When you're taking the derivative, you just got to remember to use the product rule. The quotient rule, it's very specific. And because of this minus, it has to be the bottom times the derivative of the top minus the top times the derivative of the bottom. So this one you have to keep straight. If you do anything a little off, then your derivative will be wrong. Okay, so let's go back to our example. And our example was, let's see here, y equals 2x squared minus 4x plus 3 all over 2 minus 3x. And we wanted to find y prime. So to do that, we take y prime. Alright, so let's go through this. We have the bottom, which is 2 minus 3x. We just rewrite that again. And then we need the derivative of the top. So the derivative of the top, derivative of 2x squared is 4x. The derivative of a negative 4x is a negative 4. And the derivative of 3 is 0. Then we subtract the top, which is 2x squared minus 4x plus 3, and multiply that by the derivative of the bottom. So derivative of 2 is 0. The derivative of a negative 3x is a negative 3. And then we divide the whole thing by the bottom squared. And so we end up with y prime. Let's multiply this through. So 2 times 4 is 8x minus 8 minus 12x squared plus 12x. Let's see here. The negative and the negatives cancel out, so we get plus 6x squared minus 12x plus 9 all over 2 minus 3x squared. And so y prime ends up being, let's see, we have a negative 12x squared, so that's a negative 6x squared. We have 12 minus 12, so plus 8x. And then we have a negative 8 and 9, so plus 1, all over 2 minus 3x squared. And here's our answer. Okay. Now some students, and rightfully so, ask, well, do we have to multiply that out? And it's kind of one of those fuzzy, unwritten rules in math, but for whatever reason, over time, we've just kind of gotten used to the idea that when you're using the quotient rule, when you square the bottom, you actually don't have to multiply that out unless, you know, it's something that's going to benefit us later. So a lot of times when you look at the answers of these things, they actually don't multiply those out. So it's fine to keep it like so. Okay, so here we have the quotient rule. Okay, and even though it was a little bit of a derivation, we were able to come up with our rule for the quotient, if you have a quotient as a function. And you're going to have to choose something to help you remember this. And here was an example of using that quotient rule. And another big thing is remember that when it comes to the quotient rule, order does matter. So you definitely have to be specific about where you put the functions and their derivatives within this rule.